Hello, this is Michael Liu here, doing number 20 on page 245 of the textbook in the applications and problems section, chapter 8. So number 20 asks, a chromosome has the following segments where the dot represents the centromere of the chromosome. So what types of chromosome mutations are required to change this chromosome into each of the following chromosomes? So that would mean the A through I, they all have some type of mutation, and it's just asking to recognize what type of mutation it is. And this would be the base chromosome that the mutation occurs in. Okay, so for letter A, going through, I'd immediately see there is a duplication because A and B repeat, and it should be just A, B, C, D, and go on like that, but it is also a tandem duplication. And a tandem duplication is that when the things being duplicated, they end up being right next to each other. So AB, AB, that says tandem duplication. If it was a displaced duplication, that would mean like the AB exists, like a second copy of it exists, but let's say the AB is here rather than right next to what it was duplicated by. So for A, wrote down tandem duplication. Okay. B would be another duplication. I could tell already because, well, it's longer than it's supposed to be. So if there's added nucleotides, then there must be a duplication going on of some sort. So A, B, C, E, A, B. So again, so it was like exactly what I just said. The displaced duplication happened because AB ended up somewhere entirely else on the chromosome. So in this case, displaced duplication. Okay, and then for C, A, B, C should be D, E, F, G. So this would be an inversion because like the ordering got switched. So instead of D, E, F, it's F, E, D. So these three nucleotides, they went through an inversion, but now I'm gonna think, is it a pericentric or paracentric? And then pericentric means that it includes the centromere inside the inversion, and in this case the inversion happened completely outside of the centromere. So that would mean that it is a paracentric inversion. And the only reason why it's a paracentric inversion is because it didn't include the centromere. Alright, A, okay, C, D, E, F, G. Okay, so this is just a deletion. D is just a deletion of that single nucleotide, the B lettered nucleotide. So it would be a deletion. And then in my head, I'm also thinking, well, a deletion in the textbook, it can lead to haploinsufficiency, which is where, let's say, a trait, in order to be expressed in the phenotype, there needs to be 2 copies of that chromosome or that gene in order to express it. So then when one of the chromosomes, it got that gene deleted, that phenotype will no longer be expressed. And then also what I'm thinking is pseudodominance. And can be a result of a deletion, which is where basically the recessive phenotype is expressed, even though the genotype would say that the recessive phenotype should not be expressed. And that's, again, because the gene got deleted. Okay, so E, I'm looking at E right now, A, B, C, D, E, F, G. Yeah, it looks like just the FG was deleted, so that's just another deletion. And then okay, looking at F now, A, B, okay, should be C, D, E, F, G. This is this would be a pericentric inversion. No, alright, it's still paracentric. Again, I got a little bit confused because maybe I thought of this as being part of the centromere, but really, it's just these three nucleotides that are being inverted, which that does not include the centromere. So if it doesn't include the centromere, it is paracentric. Paracentric inversion. Okay. Now on to G. Okay. There is a pericentric inversion, A, B, D, E, F, G. And there's no deletions because all the letters are still there. There's no duplications because, well, there's no extra letters. And the inversion came from A, B. It should be over here. And this, in this case, this whole thing is related to the inversion. And within this whole thing includes the centromere. So if the centromere is included in an inversion, it is a pericentric inversion. Okay, H, like immediately my mind's thinking there's gonna be more than one here, probably. A, B, C, D, E, F. Okay, there's a duplication because there's multiple F's, multiple D's, multiple E's, and then an inversion. Okay, so the duplication is tandem because of DEF, DEF, that's what was duplicated. They're right next to each other. So DEF and DEF are right next to each other. That makes it not only a duplication, but a tandem duplication. So I'm gonna write tandem duplication. But in addition, it is also an inversion because it should be DEF going this way, not going that way. So that just says it's an inversion. And it would be a paracentric inversion because the centromere is not involved. And then for I, there would be a duplication because of so many extra nucleotides. And in addition to that duplication, okay, so looks like DEF got duplicated. And then in this duplication, it got inverted. So, and it's not only just a duplication, it would be a displaced duplication because there's a DEF and whatever, the DEF are not right next to each other, so that makes it displaced duplication. But then also there's an inversion going on because it's not DEF, it's DEF going this ways. So for my answer, I would put displaced duplication and an inversion. All right, and that would be it for this problem.